I'm John, talking about troubleshooting GCS nodes, trying to we're going to talk about, here's the outline. We'll talk about some common problems that you'll see setting it up, ways to rectify them, and diagnose them, gather up information that's useful for our support team. So some of the useful tools that when you're diagnosing the systems to have are listed here. I won't go through each one. I think that most of them are really familiar to people. One that may not be is Globus Connect Server Self-Diagnostic. That's a tool that we package with GCS. So if you have GCS, you'll have that tool. It inspects your system, gathers up information that's very helpful for support, but can also be helpful for you in self-diagnosing and self-rectifying GCS nodes as well. And we'll talk about that one a bit. Okay, so the first problem that people commonly see are firewall issues. No network path to the services from places that need to connect to them. So this slide shows what we need from the firewalls for Globus transfer to be effective with its data transfer nodes. There's another talk that we did a few weeks ago on this. So if you want to deep dive into the network requirements and what is actually going on, there's another talk for that here. I just want to present what we need. And what we need is Globus services need to be able to connect to any given data transfer node on port 443. So any endpoint could have multiple data transfer nodes. In fact, I recommend it. Each one of them needs to be addressable on port 443 through a firewall. It's very common for a firewall to be in front of these things, and Globus needs to be able to connect on that HTTPS port. The more complicated one are the two endpoints need to be able to talk to each other. So a sender needs to be able to connect to a receiver in order for data to flow. And the way that works with Globus is by default, it doesn't have to be this way, but this is by far the most convenient if you can set it up this way. Senders are always forming TCP connections in an outgoing direction, and receivers are always accepting those connections. The port range is 5,000 through 51,000 that needs to be open. These are ephemeral ports, so don't let that scare you too much. But again, I'm not going to get into too much of the details in this talk. So the sender needs to be allowed to connect out to any given receiver listening on that port range. Receiver needs to be able to accept on that port range. Those are the requirements that we have. So let's talk about what it's going to look like if those requirements are not met. So first, 443 is blocked. What you're going to see is when you go to the web app and you want to look up your collection. I'm going to screw up collection and connection a lot, I've noticed. So bear with me on that one. Okay, so you go to, look up that connection when it's trying to figure out what files are there and present them to you, do a directory listing. You're going to get some timeouts. It's attempting to connect. Eventually, it gives up because it cannot hit that port 443. That's a pretty telltale sign. Another is you run the Globus Connect server tool suite. When you're first setting up an endpoint, a common one is endpoint show. That's a pretty good one to test it with. If that hangs for a really long time and then eventually gives you a connection error, you probably have port 443 blocked. The nice part about when the problem is 443 being blocked is it's pretty obvious. You can do almost nothing. You need that opened up to Globus services. If it's not, you're going to basically have no interaction with the Globus tools. That's a very good suspect at that point. So to troubleshoot it a little bit further, just to verify that that is what it is, there's some tools you can use to make sure there's connectivity into your data nodes. So like I mentioned, you can have multiple data nodes behind a single endpoint, and you're going to want to verify each one of those. Typically, they're all behind the same firewall, but that doesn't mean the firewall is configured to allow access to each one. It could be just on, one or all but one. And you can use a tool called dig, which is basically just like NS lookup or all it does is it does a DNS lookup and it reports back the information it got. I have some options listed here that just make it a little bit nicer. Here, I'm just saying dig these options and this DN name. Yours will probably end in globus.org, or if you've configured your own DN name with that. This is just my test instance, why it looks like that. So I run that and it reports back, okay, there's 2 IP addresses registered behind them. And now I know that. Now I want to verify that path to each one. And for that, I can use curl, which I'm sure that everyone's familiar with, but just in case you're not, all it does is by default does an HTTP GET of an endpoint. Very clean, simple tool. And what we have an endpoint on Globus Connect server called API info. I'm sorry, I shouldn't say endpoint. That's the path in it. And that's a good one to use because it requires no authentication. We don't have to worry about like getting you a bearer token or anything like that. You can just hit that one directly. So that's when you want to go to with curl. An important option here is this resolve option. It's a really nice feature of curl, really. So if you say resolve the host name you're going to look for and the specific IP address, instead of going to DNS and looking it up and picking one of the IP addresses that it gets back, it'll use that specific one with that specific host name. So all the HTTPS certificates will work out and you know you're hitting that source. So what you'll want to do is run that command against each one of these IP addresses. And if they're all coming back with a timeout, it's almost certainly a firewall issue. Maybe only one is, but that's a way to verify that route to it that you can actually connect in. And if you can't, firewall is a pretty good suspect. Okay, so what about the data channels? As I mentioned, senders need to connect to receivers in order to send data. So this one's a little bit trickier because it's not it. You can do some things like you could go to the web app, list your collection, see all the files, then you go to do a transfer. And what you're going to see if you drill into the event log in the web app, that's one of the options when you're in there. I'm not going to get too much detail there, but it's very findable. Um, you'll see something like, okay, you requested a connection. I'm going to start it. Oh, it failed. I'm going to start again. Oh, it failed. And it's just going to keep doing that. We're going to be retrying, but because that network path between sender and receiver cannot be established, it's always going to fail. A telltale sign of this is if you drill into one of these events and you get a window like this one up, is you'll see a command of retrieve, which means send this file, or store, which means receive this file. That means it's trying to transfer. And if you get a failure on that, particularly a failure that starts with 500 Globus XIO, it's a really good indicator that those two cannot connect to each other, likely a firewall issue. You can further test that for the data nodes if you have SSH access to that specific node with a tool called Netcat. Netcat is basically just like a TCP Swiss Army knife. I think that's what the hell they advertise it even. So on the receiving host, the destination host, you would listen on some port within the port range. I picked 500 just because it's in the middle. And on the sender, you would run the connect command. If they fail to establish a connection, very likely a firewall issue because the nodes are up, you're SSH into them. It's almost certainly a firewall issue on that port. If that does succeed, you can do a further step and verify it with an OpenSSL client and server, which will, sometimes firewalls will reject things based on traffic, and this will help diagnose that. I'm not going to run through those commands because there's quite a bit of cert set up and there's some other uh, complications in that, but there's a link to it. We have it really well documented on our webpage that you can walk through that to run that to help verify that. But if ultimately you detect that you don't have connectivity through your firewall on the ports that we need, there's not a lot you can do about it other than talk to your network administrator. I mean, unless you are the network administrator, obviously, but we just need those ports open for transfers to be successful and in order to connect to the various GCS nodes in order to do basically anything there. Okay, so now let's move to down nodes. So again, you can have multiple nodes behind an endpoint. So basically horizontal scale out. And from time to time, one of those may not be available, one or more may not be available. And let's take a look at how that manifests itself. So first, I'd like to talk about how we do our load balancing, like how a node is selected. So with GCS, we don't have a load balancer in front of the data nodes. What we do is we use DNS round robin to, was there a question?
I think it was just background noise, Buzz.
Okay, cool. So yeah, so we what happens is each node registers its IP address behind the same host name. And DNS round robin is a feature for with DNS that's been around forever. It will return all of the IP addresses on any given lookup, but in a different order. And then the clients can select which one they're going to use. An important thing to note here is that a lot of that behavior is up to the client. The DNS round robin isn't dictating it, it's just kind of suggesting it. Because again, it gives you them all, but it'll change which one's first. Now, many clients are going to take the first one and connect to it. And if it fails, they're going to say, oh, it didn't work. And then they could look up another one. The next time they'll get another one, right? Others are going to walk the entire list until they get a successful one. And others are going to cache the last one they use. It's just going to depend on the behavior of the programming stack that they're using, the software stack that they're using. But the takeaway here is that when there's a down node, particularly when you have replicated nodes, the errors are going to be consistent, but not always, right? So if you have three nodes, one's down, you're not going to see it 1/3 of the time, but if you do it enough times, it'll probably normalize to 1/3 of the time. Point being that you're going to see it a lot, but not always. So I made this little animation, which was fun, but time consuming to sort of beat this point home. Okay, so in this situation, we have like three Globus data nodes behind a single endpoint. And oh, wait, no, backwards, sorry. And they need to register their IP addresses as they come up behind the domain name. So they register all the IP addresses. When a client wants to interact with that endpoint, it looks up the host name, it gets all the IP addresses back, and then it selects which one it's going to do. Very commonly, it will take the one on top, and that will be, round robin ordered. So it connects to the first one. Another client comes in, looks it up, connects to the second one. So now the third one's down. Okay, so now it on its third lookup or a third client comes along, it tries to go to the third one and it fails, right? But then it tries again, it succeeds, tries again, it succeeds, again, it fails. So just showing how that works. We don't do anything automatically to detect this and remove it from the lookup. We are investigating solutions for that, but as it sounds right now, that won't happen. This will be the behavior you'll see. We'll talk about how to rectify that. Another way to identify this is if you start a transfer and one of the nodes is down, something that you might see or likely will see at least eventually is that you'll get a lot of failures, a lot of connection failed, um, but it will eventually succeed, right? So it's trying, it's going to hit the bad one, it's going to fail. Maybe it hits the bad one again, it's going to fail. Maybe it's caching it. So that happens a few times, but eventually it finds a good one. It works out and it succeeds. So this is not to say that that's okay, right? No, nobody's happy about this behavior that it's down. Globus transfer is designed to be very reliable and to get the work, like fire and forget, get the work done. But you don't want this. You don't want your customers having their transfers taking longer than they have to due to these failures. We want to fix this situation. And this is just a way to identify it. Another way is directory listings working sometimes, but not other times. If the node's down, Globus tries to connect to it on port 443. It might fail if it hits the bad one, or it'll work if it hits the good one. And you'll get the similar timeouts to the firewall issues. And actually, a down node is very often going to look a lot like a firewall problem, only just not all the time. That's sort of the way to kind of sniff out the difference, right? Like if it's working but failing sometimes, probably down node. If it's just never working and they're all behind the same firewall, which is very common, probably a firewall issue. Similar ways to diagnose them, though. Okay, so what would cause a node to be down? Well, one would be there's some bug in our software, right? But uh, very often it's just because we're in a distributed computing world, things fail. That's just how the cookie crumbles kind of thing. Somebody could have tripped over the network cable. The machine might be too busy, so it might self-rectify. Various things, but just generally machines fail. So it's a reason a node could be down. So let's talk about what do you do about it if your node is down? We want to fix it. The first thing you got to do is determine what's good and what's bad. And again, the way to do that is similar to the firewall issue. Run the dig command on your hostname, get all the IP addresses, then do the same curl command, again using API info because it's You don't, it's not secured. You can just use it with each IP address. If you get a connection timeout issue, uh, that one's down or inaccessible at least. And if you get good ones, those are up. So take note of the good ones and the bad ones, the good IP address and the bad IP addresses. Okay, so if at least one is healthy, this is the process. If they're all down, it's a similar process, but a little bit different implications. So if one is down, what you want to do is disable it. Disabling it effectively just takes it out of the DNS round robin pool, which means your clients are no longer going to hit it, right? They do a lookup, they do try to do a transfer. All of them are good. It's not getting that one bad one every now and then. So, those transfers are working without issue. You have time to fix it and then bring your cluster back up to full strength. Uh, so what you do to do that is our Globus Connect server command line tool that's used to set up the nodes has a lot of functionality in it, and one is listing the nodes. Okay, so we know that one of them is bad, and we don't want to attempt to talk to that one because it's just going to fail and time out on us and frustrate us. So we have this option in Globus Connect server, use explicit host, which is basically the same thing as that curl resolve. What it's saying is, okay, I know that you're going to look at this DNS entry and there's going to be many IP addresses against it. I don't want you to use one of those. I want you to use this host because I know it's good. So you want to use that. That's why you take note of the good ones. So Globus Connect server, use one of your good hosts, list the nodes. And what you're going to get back is similar to what you get back from dig, but with some additional Globus specific information. In this list, there should be the IP address that you noted was bad. Okay, so that's the one you want to disable. And you disable that Globus Connect server again. We have the node update command with disable. Again, use explicit hosts against the one you know is good. And you disable it by giving it the UUID of that bad node. So in our case, 8213 is good. So we use that as use explicit host. 85215 is bad. So we copy that URL, put it there, run that command. It's disabled. Now it's out of the pool. Now you have a little bit of breathing room to work to bring your cluster back up to full strength. So if no nodes are there and healthy, you can't do that, right? You can't disable it because you don't have any nodes to talk to. The nature of having no services running is your users are just going to have downtime. Sometimes that's an acceptable solution. People just want to run one and they know things fail, so it'll be down. The solution to bring them back up is very similar, and I'll talk about that in a second. One thing I want to drive home here is when you set up an endpoint, you got to hang on to your deployment key. There's no real good solution, particularly if all of your nodes are down without that deployment key. So when you set it up, that's something you got to put in your vault and make sure you have in order to solve problems later or expand your cluster or basically anything. You need that. So just making a note of that here. Okay, so replacing a down node. Again, you have to have the deployment key. The process is going to be that you install a new node. This link here talks about how to do that, but it's basically the installation guide. One of the steps is you install a new node, same process. You have that deployment key, you use it to set up the node, and once you have the new node there and it's healthy, you delete the node that's not healthy. So these are the steps in doing it. So Globus Connect server, setup okay, so first, back up a little bit, bring up a new VM. This is the nuke it from orbit situation. This is not the I'm going to fix my node situation. This is a node is down, kill it, bring up a new one. Sort of the distributed computer mantra of treat them like cattle, not like pets, which is something my vegetarian daughter would hate to hear, but it's a reasonable approach in software. Software doesn't have feelings. So yeah, you bring up a new VM, or if you have hardware, whatever it is that you're doing to bring up a new node, get that all set. The installation guide will talk about the software you have to install. But for setting it up, once that software is installed, it's Globus Connect server and node setup. Again, you're going to want to use that use explicit host command on that. I didn't here. Sorry about that. And give it the deployment key. And what that'll do is install more software, configure software, talk to Globus use the information in the deployment key to add this node to your endpoint. Once that's done, you can then use Globus Connect server and use explicit host and local host this time because now you have a node that's in the system that you're on, so you can very conveniently use local host. This is really if all of your nodes are down and you're bringing up a new one to get the endpoint active again, local host is very convenient to use because you're on that machine. You know this is the good one, the only good one in this case. So use that switch and node list. So when you do the listing, again, you'll get the list of IPs that we showed before. In this case, in this example, this is the case where I had two nodes. One of them was bad. It went down. I disabled it, so it's marked as inactive. The other one's active, and there's a new one active because I just added it. So now bringing my cluster back up to full strength, which is two nodes here, I can now delete the bad one. So Globus Connect Server, node delete, that UUID, that'll take it out of the list. I don't have to worry about that one anymore. And my cluster is back up to full strength. Okay, so now I want to dive into some details that are going to help rectify a down node. So we don't always have to just completely destroy the thing, right? There might be some admin tasks we can do that are going to bring it back up much, much quicker, maybe cheaper, easier. The first thing I want to talk about going down that road is GCS Assistant and what it looks like when that's down. So to know what it looks like when that's down, let's first talk about what it does. So I mentioned that Globus Connect endpoints can have multiple data nodes behind them, horizontally replicated, uh, and they need to have a sync and state, right? If you connect to, as I mentioned, you want to add a credential or something of that nature. You go to that DN endpoint, it points you at one of the Globus Connect server nodes and adds the state. Well, something needs to synchronize that state. Well, Globus Connect Server Assistant is the thing that does that synchronization. It uses our configuration management service and AWS AppSync behind the scenes, but that doesn't really matter. The main thing is that this is the thing that's going to have the configuration files, the object state, each node eventually consistent, right? It's bringing all that state so that they're all doing the same thing. They all agree with each other. Um, it also interacts with Globus Transfer and Globus Auth to provide information there that's needed for consistency between central command and your Globus Connect server installation. The other thing that it does is it renews certificates. So each node is speaking HTTPS, and they all have to have a valid certificate. Our certificates are valid for 90 days. They're renewed once it's 60 days old. So Globus Assistant is handling all of this. Okay, so when it's down, what happens? Well, a common one and an interesting one that shows some of this functionality is the expired certificate error. If Globus Assistant is down for a long time, eventually you're going to see certificate errors. This does come up. The other thing that happens is you'll see other synchronization issues, like I mentioned the credentials. So if you add credentials and Globus Assistant is down on one node, it will uh, the credentials will be replicated out to all the other ones, but one of them won't have it. So you'll start seeing things like resource does not exist in your error messages or um, uh, resource conflict, these types of things, because they're not in sync. And sometimes it'll work and sometimes it won't. A similar thing like that. However, if Assistant is down for a long time and you're not creating new collections, you're not creating new credentials, you have your GCS cluster running and configured how you want it, and you're just doing transfers, it could be down for a long time and everything will be going fine until the cert expires. And that does happen. So that's when people start thinking, well, it was just working. This doesn't make any sense. I haven't touched anything. Well, the system might have been down for a long time, or it might have been down at exactly the right time to miss that cert renewal. Okay, so that is talking about Globus Assistant, which is one of the main services that you can do something about. But let's talk about like the diagnostics to look more into it. And I'll talk about how to solve a problem if Globus Connect. I keep saying Globus Assistant. Sorry about that. I'm just going to call it Assistant from now on. That's a lot easier. Less words, which I know one of my teammates is very much into. fewer words when I talk, which is maybe why I'm giving the talk. Anyway, so diagnostics. The process of gathering the information on Assistant is a lot like any of the other services. So we'll talk about that now, and we'll talk about how to rectify it. I mentioned this earlier, our self-diagnostic tool that comes with our CLI. Very useful, particularly if you're submitting a support ticket of you'll probably be asked for this information. What it does is it introspects your system, gathers up, information about it, the Linux distribution, the IP addresses behind that endpoint, the endpoint name, our configuration files, all kinds of stuff like that that can then be useful for us when trying to debug it. But it also does systemd status. So systemd is the Linux service manager that allows you to run these services, and it babysits them and runs them and manages them. And it will also tell you if they're running, if there was a problem with them, and log information about them. This is the main thing you can do to rectify problems on any given endpoint. Okay, so these first four services are the main things that we run out of systemd. Apache is the HTTP service that's kind of routing all the information to our other services. GCS Manager, that's where we run our own endpoints like that API info. That's what you talk to when you're going to create a collection or a gateway or credentials or any of that stuff. That's our REST application. Assistant I talked about, and Globus Grid FTP server. So all of those need to be in a running state in systemd. And if they're not, you can restart them to solve them. Let me get into that a little bit more after I go through the output from the diagnostic tool. So when you run the diagnostic tool, and I apologize for the slide, I was looking for a way to be able to have a huge text wall that I could scroll through in slides, but I couldn't figure it out. So I did it this way. Here we see when you run it, the first things you're going to see are like inspection information, its IP addresses according to IP-adder, etc OS releases, so information is sent in boot to a machine. That kind of stuff is going to be spit out there. The next is going to be configuration information. We'll cat all that out, the solid information that can help you diagnose things. You'll see down here, it will do a lookup of the IP address and report back. I'm sorry, a lookup of the domain name and report back the IP addresses. It will even try to connect to them to verify that there is a route. That can sometimes lead to false positives. That's okay. Won't get into that too much here, but the main thing is this is all information that you're going to send up to support. Some of this may be helpful to you, but mostly the main thing that you're going to want to key in on is the system control status. So this is the command it ran in this case. System control status Apache 2. No pager, lines 10, just some information. And what you want to look for is it active? Is it running? If it's not, it's going to say dead or exited. There's different states of it, but for the ones that I mentioned, Apache, Assistant, GCS Manager, and Grid FTP, you want those to be running. If they're not running, that's a problem. And lower in the output, it goes through all of these in the diagnostic output. I just couldn't fit it on the screen, as I mentioned there. Okay, so this is what it's calling. System control status, each service name. So if you see a problem there, these are the steps you want to take. Okay, the service that's down, run system control status service name, you're going to get a bunch of output. If you see that it's not running, system control restart. Great, now it should be running again, but it might not be, right? Maybe it exited right away, maybe it crashed right away. Next thing to do is system control status, that service name, see if it's running. If it is, great. You may have just fixed your system or your node, sorry, particularly if it's Assistant. Sometimes I think we have most of those bugs fixed. We're working on that, but it could have crashed and not restarted. If you restart it, you may have solved it and be good to go. If you do run status again and it is dead again, you can get more information out of that with this journal control program. That's just one of the tools associated with systemd, and it'll output information about it, whatever it's sent to standard out or standard error, other things as well. I have this next slide kind of shows that. So this is running it on GCS Manager Assistant. And this is the output that you get. A lot of this output is not going to be helpful to people who didn't are not familiar with the source code, but some of it might be. You may see permission errors. You may see things like that that you are able to solve. The main thing is if it's dead, you start it. If it's still died, it might be time to file a support ticket, but gather up this information as well because this is used for information and take a look at it first in case there are some obvious problems there. Okay, so while we're talking about gathering logs, there are more logs that we can gather. So that would be, that one is the journal control command is good for all of them, but particularly good for Assistant to get information out of it. But there's others. So this first file, the GCS log file, that's where you're going to find information about our REST application server. Um, it logs at a lower level by default, and that's going to show errors and warnings. And that's where you may see things that you can fix. Again, typically like permission errors or user doesn't exist errors or things that'll start, maybe triggering in your mind other admin tasks that were done that maybe conflicted with things that Globus needs. You can also increase the log level to debug. If you're going to file a support ticket, this is a good thing to know how to do. It helps us out a lot in debugging it. And the way that you increase that is you add this GCS manager log level equals debug line to one of these two files. If it's rel based, it's the top one. Debian based, it's the bottom one. Okay, so similarly, grid FTP logs. This is where it's at. And to change the log level, it uses like a configuration D type of situation. So you can just add a new file under that directory. We, by convention, use Z logging because it's going to go in alphanumeric order. So that's going to be later and it'll override anything else. And if you just put log level all, it'll provide a ton of information in it. Again, most of the higher level, like debug log logging, is not going to help you debug your system, but the default ones might. You may see errors in there that you can do something about. Um, then these next two are definitely really only going to be for filing bugs, but they're interesting to know about and to make a little bit of sense of in case support asks you for them. What you can do is add, we have standard type logging that's common in all services, but then we have this trace level logs that will go just by module. They help us zero in on um, problems in specific areas. So for example, this first one, Globus Grid FTP server debug, they go by module. So this would be the main kernel of the Grid FTP server, and it's saying log everything to this file. Okay, just from that core. But let's say, you have a connector that's talking to Box or S3 or something of that nature. It's going to make REST calls out. So we can also log the REST calls. This is one that could also be helpful in your own personal debugging, actually. And this line here, what this is saying is log everything, but not data, because you don't want to see the data. Like if you're transferring a file, all that binary information we don't want to put in a file most of the time. So this is a good line to put. That'll log it to, in this case, /temp rest debug, but it can be any file you want. And in that, you'll see calls out, like gets, posts, that kind of thing, and the responses. And sometimes that can help you figure out what's going on with the upstream system, particularly in the premium connectors. And then you can drill down further into each premium connector as well. In this case, like Globus S3 debug, all goes to that. So a lot of interaction, a lot of logging lines from our software in the connector will go into that kind of like trace information. And similarly, just another example of Globus Google Drive, debug, all that information goes there. Of the four of these, the second one is probably the most useful for your own troubleshooting. But all of them, and of course, there's others according to name. And if you're contacting support, they'll tell you the right string to put in there. I'm only talking about it here to sort of familiarize people with it. All of them are useful to us, but the second one in particular could be useful in your own debugging. And then the last thing that you might be asked to do in gathering up information for us to help debug your systems is an strace, specifically, well, often on GridFTP, but probably on GCS as well. And what that does is people are probably familiar with that tool. It's not our tool. It's a standard Linux or Unix system tool. It will log all the system calls from a given process. And that can help us see like what was going on, why did it call, a lookup twice, etc. Things like that, really for our debugging. And on that again, you'll be given the command if you contact support. Okay, so that's pretty much what I have. These are some links. This slides will be online and available. So these are some references that go into some of these topics in more detail and in text, so they're easier to cut and paste. But other than that, that's what I have for you, and thank you.